morning. I am Devisena. In this lecture, we are going to discuss about medium access and overview. This topic is present in the subject wireless networks. Open Systems Interconnection, that is OSI model. The Open Systems Interconnection model is a conceptual model that characterizes and standardizes the communication functions of a telecommunication or computing system without regard to its underlying internal structure and technology. The purpose of the OSI reference model is to guide vendors and developers so the digital communication products and software programs they create can interoperate and to facilitate a clear framework that describes the functions of a networking or telecommunication system. This model breaks down data transmission over a series of 7 layers. Each layer has a responsibility to perform specific tasks concerning sending and receiving data. Let us see 7 layers of OSI. This OSI is broadly divided into two portions. One is lower layers and other one is upper layers. The lower layers comprises of physical layer, data link layer, network layer, and the upper layers comprises of transport layer, session layer, presentation layer, and application layer. See the wireless network internet representation with a small animation. This is a network, wireless network, as well as the internet. We are having so many gadgets. These gadgets are connected to the internet through the wireless medium, that is to the wireless network. Here we are having so many gadgets. These gadgets are interconnected with the help of the internet. This is indicated here. See how the transmission and reception of data takes place between the 7 layers of OSI model. This is the representation of a 7 layer of OSI. In one end, the data is being transmitted. The node is now transmitting the data. It is passed to the application layer. From the application layer, it is passed to the presentation layer. From the presentation layer, it is passed to session layer, then to transport layer, then to network layer, then to data link layer. Finally, it reaches the physical layer. The data is now in the transmitting side. It is passed to the receiving side through the medium. The medium that is used for wireless transmission is air. Air is a working medium. Now, in the receiving side, the data is available in the physical layer. From the physical layer, it is passed to the data link layer, and from the data link layer, it is passed to network layer, then to transport layer, then to session layer, then to presentation layer. Finally, it reaches the application layer. Then from the application layer, the information is reached the destination. That is the node, destination node. This is represented here. Let us see lower layers of OSI model. Layer 1, it is physical layer. Electrical signals and cabling done in physical layer. Layer 2, data link, that is MAC layer. Transmits packets from node to node based on station address. Layer 3, network layer, routes data to different LANs and WANs based on network address. Let us see upper layers of OSI model. Layer 4, it is transport layer. It ensures delivery of entire message or file. Layer 5, session layer, starts, stops session, maintains order. Layer 6, presentation layer, that is encryption, data conversion, ASCII to EBCDIC, BCD to binary, etc. Layer 7, application layer, types of communication, email, file transfer, client server, etc. Need for medium access. Medium access control protocols are mechanisms that allow users to access a common medium or channel. Their variants, Aloha, slotted Aloha, carrier-sense multiple access protocols are used a great deal in communication networks. Let us see data link layer. This data link layer is placed in between the network layer and the physical layer. Data from the network layer is passed to the data link layer, and from the data link layer it is passed to the physical layer. And this is indicated here, and from the other side, it is from the physical layer, data is passed to the data link layer, and from the data link layer, it is passed to the network layer. It is represented here. Let us see the divisions that is present in the data link layers. This is the representation of the physical layer and data link layer. The data link layer is divided into two layers. One is medium access control, that is MAC layer. It is a sublayer, and the another one is the logical link control, LLC. This medium access control layer is connected to the physical layer, and logical link control layer is connected to the network layer. See the data link layer details with a small picture. This is a data link layer. This data link layer is having two portions. The lower portion is connected to the physical layer. That is, the medium access control portion is connected to the physical layer. The upper portion, that is the logical link control layer, is connected to the network layer. Here, the informations that should be present in the data comprises of the destination address, source address, other header, frame footer. This information has to be present in each and every data that has to be transmitted and received. Access control, that is MAC sublayer. The medium access control is a sublayer of the data link layer of the Open System Interconnections reference model for data transmission. It is responsible for flow control and multiplexing for transmission medium. It controls the transmission of data packets via remotely shared channels. Let us see multiple access techniques. Multiple access is the use of multiplexing techniques to provide communication service to multiple users over a single channel. It allows for many users at one time by sharing a finite amount of spectrum. The available bandwidth is subdivided into a number of narrower band channels. The commonly used multiple access techniques. Frequency division multiple access, that is FDMA, time division multiple access, that is TDMA, code division multiple access, that is CDMA, and space division multiple access, that is SDMA. Let us discuss about frequency division multiple access, that is FDMA. FDMA is the process of dividing one channel or bandwidth into multiple individual bands, each for use by a single user. Each individual band or channel is wide enough to accommodate the signal spectra of the transmissions to be propagated. FDMA works on the principle of dividing the total bandwidth of the communication channel into a number of discrete segments and allocating each segment exclusively to a user. Guard bands are used between each segment of the frequency band to prevent interference between users. Let us see the FDMA representation. This is the representation of the FDMA. Here, each user is allocated a different subband or a channel. This is indicated in the diagram. Let us see the analogy of the FDMA with the real time. Consider a car is owned by a user. The car is efficiently used by the user means then the resource is completely utilized. Now, if the user is not using the car frequently means the resource is an idle one. The same is applicable for the FDMA also. In this FDMA, for a single user, an entire channel is being allocated. If the channel is properly utilized means then the resource that is allotted to the user is efficiently utilized. But if the user is not using the channel regularly means the resource is idle one. This is the scenario that is present in FDMA. Features of FDMA. In FDMA, every user shares the frequency channel or satellite transponder simultaneously. However, every user transmits at single frequency. FDMA is compatible with both digital and analog signals. FDMA demands highly efficient filters in the radio hardware. Let's see the advantages of FDMA. It reduces the bitrate information and the use of efficient numerical codes increases the capacity. Equalization is not necessary in FDMA. An FDMA system can be easily implemented. A system can be configured so that the improvement in terms of speech encoder and bitrate reduction may be easily incorporated. Discuss time division multiple access, that is TDMA. Time division multiple access is a channel access method for shared medium networks. It allows several users to share the same frequency channel by dividing the signal into different time slots. The users transmit in rapid succession, one after the other, each using its own time slot. Time division multiple access is a digital cellular telephone communication technology. It facilitates many users to share the same frequency without interference. Its technology divides a signal into different time slots and increases the data carrying capacity. Let us see the TDMA representation. Here, TDMA, the spectrum is allotted to individual users at a particular time slot. The user is not using the time slot means it is being allotted to some other slots. Thereby, the spectrum or band is efficiently utilized in TDMA. See the importance of TDMA. TDMA allows the operator to do services like fax, voice band data and SMS, as well as bandwidth intensive application such as multimedia and video conferencing. Since TDMA technology separates users according to time, it ensures that there will be no interference from simultaneous transmissions. Uses of TDMA. TDMA was first used in satellite communication systems by Western Union in its Vesta 3 communications satellite in 1979. It is now used extensively in satellite communications, combat net radio systems, and passive optical network, that is PON networks, for upstream traffic from premises to the operator. Basic difference between FDMA and TDMA is the definition of a channel and how it is used. In FDMA, a particular bandwidth, example 6.25 kHz at a particular frequency, example 150 MHz, is used to define a channel. TDMA technology is possible only by using intelligent infrastructure to make and control the time slots. See the TDMA representation with a small animation. This is a tower. Here we are having so many users. The users are using the tower at their allotted time slots. Let us see another animation. Multiple access. For each user, one particular time slot is being allotted. In that particular time slot, the users are using the spectrum. This is indicated here. See the TDMA frame structure. A frame comprises of uplink channel as well as the downlink channel, and this is indicated here. The frame comprises of so many time slots. Each time slot is allotted to a particular user. The information that is available in the time slot is the time slots contain data with guard period for synchronization. This is represented here. Let us see the TDMA single frame structure. This is the representation of a TDMA frame structure. The data stream is divided into so many frames. Each frame is subdivided into time slots. Each user is allocated to one time slot. The time slot contains data with a guard period if needed for synchronization. If a particular user is not using the allotted time slot means, then the slot can be allotted to some other users. In that way, the resource is being continuously or efficiently utilized in TDMA. TDMA callers use time slices of a frequency. This is a representation, a common frequency channel. Consider that two callers are utilizing the frequency channel. one caller is sending hi. The color of caller 1 is indicated as a purple color. The information passed by the caller 1 is a hi. Just consider that the other caller is sending the information go. The information sending by the caller 2 is go. It is green in color. It is indicated. This is represented in the common frequency channel and it is received in the receiver side in a correct manner. Let us see CDMA, that is Code Division Multiple Access. CDMA technology is known as a spread spectrum technique, which allows many users to occupy the same time and frequency allocations in a given band and space. CDMA technology is used in commercial cellular communications to make better use of radio spectrum when compared to other technologies. Uses of CDMA. When cell phone providers talk about a G, they mean a generation of wireless technology. But the CDMA/GSM split will still exist in any area where 2G or 3G networks are still alive. CDMA representation. This is the representation of a CDMA. A code is being generated and it is being allotted for each user. So simultaneously the spectrum can be utilized by n number of users. This is the major advantage of using CDMA. CDMA users are separated by codes. This is represented in this animation. Here we are having two transmissions. One transmission takes place indicating the purple color. Another transmission takes place indicating the green color. The purple code reaches the destination properly. Similarly, the green code reaches its destination properly. But these two codes are using the frequency channel simultaneously and the destination is appropriately or exactly received. This is indicated here. Let us discuss about Spatial Division Multiple Access, that is SDMA. Spatial Division Multiple Access is a channel access method used in mobile communication systems which reuses the same set of cell phone frequencies in a given service area. SDMA increases the capacity of the system and transmission quality by focusing the signal into narrow transmission beams. Under traditional mobile phone network systems, the base station radiates radio signals in all directions within the cell without knowledge of the location of the mobile station. DMA representation with the help of a small diagram. Here we are having SDMA, FDMA, TDMA. The SDMA technique allows frequency reuse. This frequency reuse is not possible in TDMA and FDMA. And this is indicated here. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video to your friends.